When we talk about the carbon cycle, we're often talking about the short-term carbon cycle, whereby carbon is exchanged through photosynthesis and respiration over days, years, and decades. However, geological evidence provides a long-term story about carbon dioxide levels in the atmosphere over hundreds of thousands of years. And this is the long-term carbon cycle, and that's what I'm going to talk about in this video. Measurements of carbon dioxide taken from the ice cores demonstrates that Earth's atmosphere has gone through fluctuations. Over the past 400,000 years, carbon dioxide levels have fluctuated in a repeating pattern from about 180 to 285 parts per million. These long-term fluctuations are due to the movements of carbon from Earth's carbon reservoirs. Maximum atmospheric carbon dioxide levels correlate with warmer estimated temperatures during interglacial periods. Minimum lower carbon dioxide levels correlate with lower estimated temperatures during glacial periods. In addition to biological processes such as photosynthesis, carbon dioxide is removed from the atmosphere by geologic processes that play key roles in the carbon cycle on the timescale of centuries or longer. These processes include chemical weathering of rocks, organic matter being deposited into soil, deposits of organic matter in sediments, and the sedimentation of calcium carbonate shells and skeletons. Then plate tectonics, which is just the constant motion of Earth's crust, moves carbon through subduction to volcanoes. Subduction is simply a geological process in which one edge of one crustal plate is forced below the edge of another. Eventually, volcanoes release the carbon dioxide into the atmosphere. For our role, the burning of coal, oil, and ancient organic matter sends additional carbon dioxide into the atmosphere. Some argue that the current carbon dioxide levels are simply a reflection of the long-term fluctuations we've seen over hundreds of thousands of years. But the difference is that the current levels of carbon dioxide in the atmosphere are far higher than they have ever been, and that increase is what is causing overall warming of the planet and extreme climate change fluctuations. Remember that other greenhouse gases such as methane contribute to Earth's increasing overall temperature. Impacts from climate change are being experienced by communities and ecosystems throughout the world, and they go far beyond just a simple increase in overall temperature. The changes threaten the environment. Habitats are modified, timing of ecological processes are altered, as are home ranges of many species. Also, oceans are becoming more acidic due to increased absorption of carbon dioxide, and that impacts marine life. Also, sea levels are rising due to melting ice sheets. Our water supply is impacted because climate change is causing droughts in agricultural areas and floods in other regions where it's unexpected. Our food supply is also impacted. Climatic fluctuations and changes in the distribution and abundance of pest species threaten crops, and obviously that impacts our source of food. Human health is also impacted in regions where high temperatures cause life-threatening heat stress, waterborne illness, poor air quality, and an increase in disease transmission from the increasing population size of insects and rodents. And of course, all of these things exacerbate the displacement of people from their communities. This is why climate change is considered the defining crisis of our time, even in a time of the COVID-19 pandemic. If you want to find out more about human-caused climate change, you can check out these websites.